Hello, welcome. This video is to get you up and running really quickly to create your own post-processing effects. You'll basically be set up and you'll be ready to go to start tinkering around with a shader and have the effects immediately appear on the screen. So this is the Viking Village tech demo that Unity Technologies released on the Asset Store. You can download it for free and load it into Unity as a project. I'm really using it as a kind of just a background to create the processing effects and also to show some existing effects. So if you select the camera in this project and go into the inspector view, you see a lot of scripts here attached to the camera. Almost all of these are post-processing effects. For example, ambient occlusion, global fog, bloom. You can toggle these if you want to mess about with them. So we're going to be doing the same thing and actually creating a post-processing effect right at the end of the chain, which will take this image so far and tinker with it a bit and then put the result out to the screen. So let's just stop things here. First thing you want to do is go add component and new script, so attach a new script to the camera. Now the reason for doing that is open it up in, say, your editor, MonoDevelop or Visual Studio or whatever, and you want to define the method onRenderImage. This is the entire reason for attaching the script. This allows us to hook into the ability to do post-processing. So by defining this method on a script attached to the camera, Unity will call this when the camera scene is rendered. It will pass you that image and you can then mess about with it and then output it, and in our case it will go out to the screen. So if you just run it like this, you've basically hooked into the chain, but we aren't actually doing the copying work. So you'll just end up with a black screen. So this is a good way to sort of sabotage the rendering chain, I guess. But if you want to do it, then graphics.blit, there's a method that allows you to copy a source texture to a destination. But importantly, there's a third parameter, there's an overload with a third parameter, material. You can specify material, and this is what allows you to specify a shader to use to do this copying operation, because in Unity you can associate a material with a shader. So what I want to do here is create a public field for this material, and this is so that I can set the material in the inspector. So that's this file done now. If you go back out, you'll see that on the in the inspector for the camera on the right, this is the script here, and there's this field that's been added for the material. Currently it's not set. We need to create the material, so let's create a new material. There we go. And this is where we'd select the shader that the material uses. Now at the moment we haven't created our shader, so it doesn't appear here. So let's create the shader now. And it's create shader, image effect shader. This is post-processing effect shader type. You want to select this. There we go. Let's open that in Visual Studio. Before we take a good look at it, let's change the name. So I'm going to change this to My Shaders. This is the category or the folder it will appear under, and then shader 1. You'll see what that does now. If I go back to Unity and go to the material, see in this drop down list there's now a My Shaders entry with the name shader 1. So this is how you get your shader and to organize it in this list basically. There we go, we selected it. So the material is now using that shader, so now we just need to make sure the camera, our script that attached to the camera, is using that material. So let's drag the material into that slot, and now this graphics.blit method is set up to use our shader. Let's just run it and see what happens. So wham, immediately you've got a post-processing effect working. The reason for that is, let's go to leave it running, go into Visual Studio, take a look at the shader. If you scroll down, you see as part of the boilerplate stuff, it's provided you with a kind of, I guess, a default effect. It says just invert the colors. Now this this code isn't C#, it's a shader language that's close to C. It's very similar to C#, but one of the things you'll have to get used to is the types are different. Very similar though, float 4 and float 2 are pretty much vector 4 and vector 2 that you would expect in Unity. Anything with 2 or 4 after it tends to be something that's got like X, Y, or X, Y, Z and W. In this case, this is the important part for post-processing effect shader. This is the fragment shader. This is called for every pixel of output, and it's basically, it will call you and it wants you to tell it the color of the pixel to put out to the screen. So if I give you an example, if we just comment all of that out, this is effectively the colour red. So we've got red equals 1, green equals 0, blue equals 0, alpha 1. I don't think alpha really matters for post-processing effects, but there we go. This will return the colour red. So this function is called for every pixel on the screen to ask for the colour. We always return red, so the result's going to be red, unsurprisingly. If it was blue, I'd have been shocked. So if we uncomment this first line again and have a look what this first line is doing, this method the parameter passed into this method basically provides the texture coordinates into the input texture of the rendered scene so far, which is this is the image so far that's been rendered, that's gone through all these other post-processing effects. So we're basically reading the pixel from that image at the coordinates, and then of course if you output that pixel color out, you're going to get the same image. What you can do though is then mess about with that color. For example, let's set the red component to 0, and now you can see that it's effectively an image filter that filters out the color red. You can notice you can do this live, so you can just, as long as you save the file here after you make a change and go back into Unity, it will reload the shader, and you can immediately, so you can mess about while it's running. You can do other stuff as well. For example, we could take all of the RGB, the red, green and blue components and multiply them all by 6, and you see we just brightened the image. So you can start messing about with every pixel in the scene. A lot of effects are done by modifying pixels based on various things like how far where they are in the scene, how far they are from the camera and stuff like that. Things like fog, for example. But this is all I wanted to really sort of do for this video, is just to sort of get you set up if you want to start creating shaders. This is basically it. You can start messing about in this method now. So hopefully you found this video interesting or useful. If not, then hopefully it's been short enough it hasn't wasted too much of your time. But thank you for watching, and goodbye.